Okay, so what we're going to work on today is solving rational inequalities. All right, so it's almost the same thing as what we did with the rational equations. There's some slight differences, but it's kind of taken everything that we've done over the last few days and even last week with the undefined and kind of like putting it all together. All right, so the first thing you have to do is find when the fraction is undefined. Because remember, I'm solving for x. I'm trying to find what values can I plug in for x to make it work. So I actually have to find first for what values of x will it not work. That's the undefined piece here. So when x is equal to -5, usually these problems you can tell just by looking at it. When is it going to be undefined? So obviously when x is -5, -5 plus 5 is 0. So that's called your critical point. So let's write that down. Critical point. And put down x cannot equal -5. All right, so now you're going to solve this inequality as if it's an equal sign. So x minus 4 over x plus 5 equals 4. And what you could do is you could put 4 over 1 and cross multiply. So I have 4 times x plus 5 is equal to x minus 4 times 1, which is x minus 4. Distribute the 4. 4x plus 20 equals x minus 4. Subtract the x from both sides. We get 3x plus 20 is equal to -4. Minus 20 from both sides. We get 3x is equal to -24. So x is equal to -8 when you divide both sides by 3. Okay, so now you're going to draw a number line. Remember we did that with quadratic inequality, same thing. You're going to plot -8. And you're actually going to plot your critical point, which is -5. Now, no matter what, your critical point will always be an open circle. Because remember, x can't be equal to -5, so it has to be an open circle. Now, your -8 will be based on what you have, what was given to you. And since it's a less than, that'll also be an open circle. You're going to pick test points. I'm going to pick -9. Something in between, I'm going to pick -6. And something at the other end, I'll pick 0. Okay, so let's start with -9. I have -9 minus 4 over -9 plus 5. And I want to know, is that less than 4? So -9 minus 4 is -13 over -4. That's -9 plus 5. Is that less than 4? And you can plug this into your calculator. -13 divided by -4 is 3.25. Is that less than 4? That is true, so that means we shade to the left. All right, now we're going to try -6. So I have -6 minus 4 over -6 plus 5. Is that less than 4? -6 minus 4 is -10. -6 plus 5 is -1. Is that less than 4? And this is 10 is less than 4. That's not true, so we don't shade in the middle. Now I'm going to try 0. 0 minus 4 over 0 plus 5. Is that less than 4? -4 over 5 is less than 4. Yes, any negative is less than a positive. So that's true. So I shade to the right. The last thing is that you always want to make sure that you can write the solution in different ways. So another way to write the solution besides the graphically piece up here would be to use set notation. So you write for all values of x such that it's graphed outwards. So that means you use the word or in the middle. You have x is greater than -5 or x is less than -8. Or we could use interval notation. So this goes to -infinity and goes to +infinity. So I have -infinity, comma, -8, parentheses, or -5, comma, to +infinity. Okay, so let's try number 2. All right, so let's take a look at the denominator. I have x plus 1 in the denominator. First thing you want to do is find that critical point. So what could I plug in for x here? X plus 1, that'll make it 0 when I plug in -1. So let's write that down, the critical point. And put x cannot equal -1. All right, so now we're going to solve it as if it's an equal sign. So that's 2 minus x over x plus 1 equals 3 minus 9 over x plus 1. Okay, so I want to get rid of the x plus 1 in the denominator, so I multiply all my numerators by x plus 1. All right, so over here with the 2, nothing reduces, so I'm left with 2 times x plus 1. X plus 1 and x plus 1 reduce, I'm left with minus x equals, nothing reduces with the 3, so I have 3 times x plus 1. X plus 1, x minus 1 plus 1 reduce, so I'm left with minus 9. Now I'll distribute the 2, so I get 2x plus 2 minus x equals, distribute the 3. 3x plus 3 minus 9. 2x minus x, I'm over here on the left side, is 2x minus x is x plus 2 equals 3x, and then 3 minus 9 is negative 6, minus x. 2 is equal to 2x minus 6 plus 6. 8 is equal to 2x, and x is equal to 4. Okay, so you're going to draw a number line. Put negative 1, the critical point on there, and positive 4. So the critical point is always an open circle because it can't be equal to negative 1. And then the 4 will be based on what we have up top, which is an equal sign, so that'll be a solid circle. Now you're going to pick test points. A number to the left of negative 1, we'll do negative 2. In between, we'll pick 0. And to the right, we'll pick 5. You're going to plug it in to the original. So I have 2 minus negative 2 over negative 2 plus 1. Is that greater than or equal to 3 minus 9 over negative 2 plus 1? So let's just simplify this here. We have 2 minus negative 2 over negative 1, which is positive 2. So that's 2 minus 1, which is, sorry, it's 2 minus 2, which is 0 here. And I want to see, is that greater than or equal to? So this was 2 minus 2, which is 0. And is that greater than or equal to? All right, so I have 3 minus 9 over negative 1, which is 3 plus 9, which is 12. So is 0 greater than 12? No, that's not true, so we don't shade to left. So now let's try 0. So I have 2 minus 0 over 0 plus 1 greater than or equal to 3 minus 9 over 0 plus 1. So this is 2 minus 0 in the numerator of any fraction is 0. So it's 2 minus 0, which is just 2. Greater than or equal to, greater than or equal to. 3 minus 9 over 1, which is just 9. 3 minus 9 is negative 6. Is 2 greater than negative 6? That is true, so I shade in between. And now I'll try 5. So I have 2 minus 5 over 5 plus 1 is greater than or equal to 3 minus 9 over 5 plus 1. So that's 2 minus 5 over 6. You can plug this into your calculator, 2 minus 5, 6. This comes out to be 1.16 repeating. Greater than or equal to 3 minus 9 over 6. Plug that into your calculator. 3 minus 9 over 6, and you get a 1.5. And is 1.16 greater than 1.5? That's not true, so we don't shade to the right. And then, of course, like I said before, the last thing is to make sure you can write the solutions in a different way. Okay, so besides the graphical solution, we want to use set notation. So we have for all values of x such that. Let me rewrite that. For all values of x such that. Now it's shaded in the middle. When it's shaded in the middle, you use x in the middle. You always use less than symbols. Now for the 4, it has to be an equal sign underneath because it's solid circle. Larger number goes on the right, and the smaller number goes on the left. And then set interval notation, it'd be parentheses, -1, comma 4, bracket, because we're including the 4. Okay, so that's it, and we'll practice some more tomorrow, and have a good night.